Artificial intelligence, it's very well known. Maybe not how it works per se, but well, almost everything has artificial intelligence. And one thing that is very clear are, for example, in games. You know, when you play Call of Duty alone or with just three friends in a lobby of 10, not online, those are bots. Those bots are, in fact, if not artificial intelligence, I actually think they are, but not per se. They are more programs, but they are very like artificial intelligence. Um, in games in general, you probably if you are in the artificial intelligence circle, or keep a close eye on it, you may have seen videos about maybe, for example, the artificial intelligence to beat world the world champion on chess, or any game that has a straight up artificial intelligence with it. That's very well known. In the last videos, we were talking about what I like to call, though it's not a technical term, the single player problem, which is a search algorithm that needs to find a solution to a non-adversarial problem. Meaning, pretty much, there is no opposition. So they are just trying to find a problem that has no opposition against it. Per se, for example, they were going to try to find how to, I don't know, finds a way in a puzzle, for example, like last time. There is nothing trying to counter them from reaching the puzzle. They just need to do the right set of moves. But sometimes there is a need to, to pretty much counter a counter, meaning an adversarial search. Pretty much meaning we have something that is working against us, like in a game of tic-tac-toe. Now, a game of tic-tac-toe is simple, and artificial intelligence has pretty much mastered, but it works to find it's very interesting. Let's imagine artificial intelligence, for example, doing this. This is pretty much the win state, which I'm gonna explain much more detail just a little bit, just a bit later here. There and here is our artificial intelligence. Now here's coming the adversarial part, meaning the one who's trying to counter it. This is the adversarial. The adversary. The adversary could be another artificial intelligence, or in this case, it is. In this case, we're trying to simulate as it would be, but it could also be a player, or the first one could be a player, and this would be the adversary. Now, if we follow a game, you can see that they, if we have, for example, a set of moves like this, and one artificial intelligence tries to go here, the logical conclusion here would it to be stopped. Would it to stop the winning of X, and he just then the artificial intelligence here can just do that by trying to predict the enemy's movement. And X will try something new, for example, here, where it can complete here, for example. In this case, well, we could try to counter here, for example, right here. But unfortunately for this artificial intelligence, there was a escape situation. So X win anyways, and you can see here clearly that X wins. Now, why is this game interesting? Well, it's because there's a very intriguing way of how the artificial intelligence tries to, well, tries to win this, tries get to get a knowledge of how the enemy will move to make its move. And so this specific search algorithm would be not maybe this specific, but one of that will help a lot is the Minimax. Now the Minimax is very interesting. A search algorithm that, well, follows a numerical pattern. I need, for example, three things. in a game of tic-tac-toe, three things could happen. You could either lose, you could either tie, which I think is most common, and you could either win. Now, artificial intelligence doesn't know the difference if it's not numeric. So by putting numbers in, the artificial intelligence will understand it much better. So here, for example, in the Minimax, I have that losing is -1, that tying is 0, and the winning is 1. And in this case, it's much easier because artificial intelligence can compare with math. So they can see that clearly -1 is lower than 0, and then 1, the 0 is lower than 1. So how does it, well, tries to do things? Now, here in the Minimax, we have two sets of players per se. We have the max, which aims to maximize score. Usually this is artificial intelligence. And we have the min, which, well, tries to minimize the score. It could also be the artificial intelligence. It really depends. In this situation, let's consider they are both, really. So when we look at max, which the purpose is to maximize score, we can see that it will see something like this. Not exactly see like this, of course, but it will think that, well, losing is the worst thing could happen since it has the lowest numerical value, and it would always take a tie over a win, a loss, but it will always pick from a lost or a tie. It will always try to go for a win because it has the biggest numerical value, which is what it's trying to do, getting the highest score. Now, when we see at what mean does, or what the mean part of this does, it will do the exact opposite. It will try to find a way to make either a tie if the option is between losing, or in this case, the next winning, or tying. It will try, but if it finds a situation where it can win, or in this case, make the lowest point possible, which is the circle mean, and in this case, the circle is the mean, it will always try to find a way to make, well, this lowest number. Now, it's very interesting because there are very intriguing ways of how our game works. We have the state, and the state 0, the S means the state. So we have the state, and we have S0, which is the initial state. So the player state, which returns which player to moving state, action state, result state, and action, result state, which also with action, a terminal state, and the utility state. Now, we'll explain them in more detail here. Initial state, or the S0, is very simple to understand. It's just really the initial state. For example, and what we are going to use as initial state is, well, the empty tic-tac-toe game. We could, for example, have something in the middle, or it could have a halfway game. But, well, in this case, we are trying to do from the 0. So you can see no tic-tac, no nothing here really. So that's our initial state. Now we have the player state, and this will define who will play in this situation. Where there is nothing, or from the initial state, the player will be X, and when the player X plays, the next player will be 0, and when 0 plays, the next player is X, and so on and so forth. Now we have the actions, and actions are how putting something or making an action will affect our state. So for example, here we have this set of tic-tac-toe, and what happens here in the actions are I have two sets of action I could have, which is either going to the top or going to the bottom. Now, there are consequences to my actions, of course. That's kind of the point of tic-tac-toe. So, if in this case would go a tie either way, but we need to verify exactly what will happen. So we try to look at the state, the result state, which is affected with action. So again, considering here, if my here, for example, I go with, for example, here the top, my result will be this, state. This state is after my action. So the current state plus action creates the result state, and the terminal state is more like a, well, comparer, pretty much. You will compare whether in this set, for example, we are in the terminal, which this is a terminal set or state, meaning the game is lost or won or a tie. In this case, it's neither a tie because it's tiles to fill, and it's neither a win since none have made it diagonal or a straight line. And in this case, the lower point, it's true because it has made a diagonal line with axis. Now, it's very interesting because it will always, every time we change a state, we always try to see if the state is a terminal one. And we also have the hostility state, which will compare the numerical points. So again, to see if my terminal state is either 1 or -1, which meaning, or either my artificial intelligence x 1 or either O 1, or in this case x lost. So it's just to see if we pretty much have what's our numerical value, meaning did we win, tie, or lose. Now, those are very interesting. They don't have pretty much just the game rules. But since the breakdown of a tic-tac-toe game is surprisingly more difficult than I thought, I will going to be leaving this in a separate video. But, well, if you want to see this, you have to check out, not tomorrow, since tomorrow is, well, Sunday, but Monday will be the video. So feel free to subscribe and hit the notification bell so you can receive the notification exactly when my video come out. Not just that, but check out the other videos, because if you are new here to the channel, you're probably going to be at a loss of, well, I talk about different search algorithm with search purpose. Again, the single player thing I told, which, well, is what we were going to dive in, and things like states and, well, pretty much search algorithms I talk about much deeper detail in the last videos, because, well, that was the main goal there. So again, feel free to watch them all and maybe go back here, or just, well, in case you already watched this video, but go back and you can rewatch this video so you will understand better. But I think that's it for today. Hope you like this video. If you did, comment down below any suggestion or questions, and see you tomorrow, or in this case Monday. Bye.